Hey, let's do some homework together. So first, I'm looking at number 65, and number 65 asks us to, for the following points, 2, 4, and 1, 4, find the slope of the line passing through the points. So I know that slope is y2 minus y1 over x2 minus x1. And what is that? That is simply the change in y over the change in x. How does y change? How does x change? And you just have to name these points and be consistent. So I'm going to call this x1, y1. I'm going to call that x2, y2. When I do that, I end up getting y2 minus y1 over x2 minus x1. And so you get 0 over negative 1, which is 0. So what does that tell you? That tells you that this is, as x changes, there is no, so as x changes, there is no y change. That means this is a horizontal line. Again, the change in x was negative 1, and the change in y was 0, so as you move along the x, there's no change in y. So let's look at the next one. It asks us to find an equation satisfying the given conditions. Well, it gives us a slope and a point, so I'm going to use point slope, which is y minus y1 is equal to m, x minus x1. If you do not have that memorized, definitely do. So in this case, my slope is 1/3, and my x1, y1 is 0, 4. So, of course, we could have used slope-intercept form. Slope-intercept form here. But in this case, point slope is just used more often, so that's why I'm just defaulting to it. So here, my y1 is 4. My slope is 1/3. It's going to be x minus 0. So we quickly see that this degenerates into just the slope-intercept form, which is fine, but we got practice using point slope. So that is a line that passes through this point with the given slope. Now we move on to 71. So for 71, they say, I want you to pass through these points, 2, 1, and negative 2, negative 1. So I go to 2, 1, and I go to negative 2, negative 1, and I'm trying to find out the line that passes through those 2 points. Let's go find it right now. So I know that anytime I need to make a line, I'm going to write down y minus y1 is equal to m, x minus x1, my point slope form of a line. So in this case, I guess I need to find m. So I'm going to find my slope first, and I know that that's y2 minus y1 over x2 minus x1, change in y over the change in x. So I'm going to name my points. Notice how organized I'm being with my writing. That organizes my thinking. So I'm going to have negative 1 minus 1, and on bottom I'm going to have negative 2 minus 2. So I'm going to get negative 2 over negative 4, which is a positive 1/2. So my slope is 1/2. Thus, now when I do y minus y1 is equal to m, x minus x1, I can now plug in. So I get y minus y1 of 1. Remember that y1 is up here. So my y1 is here, and my x1 that I'm going to use is here. So y minus y1 is equal to m. And remember, we just found our m, x minus an x1 of 2. So there is the equation of the line that goes through those points. But I think we can make it look nicer by distributing. So if we distribute, we get 1/2 x minus 1, because 1/2 times 2 is 1. And then we end up adding this negative 1 to both sides. And so if you add that to both sides, you just end up getting 1/2. So y is equal to 1/2 of an x. Y is equal to 1/2 of an x is the line that goes through the two given points. So that is 71, but now I need to do 81. Remember, after each one of these, I'm going back and checking my answers in the back of the book. So let me model that for you. So when I go to 65, I'm just going to double check my answer because that's something we need to do together. 0 horizontal, good, that's correct. And then 69 should be 1/3 x plus 4, which is what we got. Cool. And then I go to 71, I get a 1/2 x. Yes, that's what we got. So we've checked all our answers. So only now are we ready to go on to 81. So I'm going to go to 81, and it says give the slope, y-intercept, and graph. So if I look at 81, they give me 2x plus 3y is equal to 6. That's in what's called standard form. And we know a lot of math and science is about form because different forms have different uses and different benefits. So this one is nice because you can easily find intercepts from this form, but it's not easy to find slope. So to answer the first question of finding the slope, I'm going to get it into slope-intercept form because that form allows me to read off the slope and the intercept, and that's what they want. So I'm first going to subtract my 2x, and I get this. And then I'm going to divide by 3, and I get this. So slope is equal to -2/3, and my y-intercept is what? 0, 2. So I've answered the first two questions. That's part A and part B. And now for part C, I'm ready to graph it. I go up to 0, 2, and then a slope of -2/3 tells me that every time I walk an x of 3, if my change in x is 3, my associated change in y better be -2. So from this point, if I step out 1, 2, 3 in this direction, so 1, 2, 3 in this direction, then I must go down 2. 1, 2, so that puts me here. So I have the point on my function of 0, 2, and 3, 0. And then I draw a line, right? Cool. So I now go back to the answers to double check it. My graph looks great, -2/3 of 2. My line looks wonderful, and I'm good to go. Only now, after I've checked it, am I able to go on to 83. So 83. 83. Let's see, what is 83? Okay, it says find the degree. So if f of x is equal to 2x squared minus 3x minus 5, it wants to know the degree. Well, the degree is the highest power, so in this case, the degree is 2. And then it wants us to find zeros. But we know that zeros are just x-intercepts, and the x-intercept is where y equals 0. So I take my whole function, f of x is just y, so I set that equal to 0 and solve, right? So we know that if we have stuff equal to 0, that is fantastic. We can just factor that left-hand side. So what do we know? Well, let me model for you how to factor that. In case you don't remember, the AC method is very helpful. What we're going to do with the AC method is we're going to pull the first term over, pull the last term over, and we're going to break up B into 2 terms so that we'll have 4 terms, and that will allow us to factor by grouping. So how are we going to bust up B? Well, I need 2 numbers. So A times C in this case is 2 times -5 or -10, and B in this case is -3. So I need 2 numbers that multiply together to get -10, but add together to get -3, and yes, you guessed it, that's -5 and 2. So those are the 2 numbers that will help us break up negative 3x. We're going to break up that negative 3x into 2x's and negative 5x's. So this breaks up into 2x's and negative 5x's. So now we've just changed the form from this to this. And why do we like 4 terms? Because we can now factor by grouping. I look at the first 2 terms and what's common. I can pull out a 2x. What's left behind? 2x times what gives me 2x squared? It'd be an x. 2x times what gives me 2x? It would be a 1. So now I know over here in parentheses, I hope I also get x plus 1. Well, what would I have to factor out? Yes, you guessed it, a negative 5. So now I see 2 large terms when I look down because they're separated by this 1 minus. What's common to those 2 terms? Well, I see an x plus 1 that lives in both. So I pull out that x plus 1 to the front. Pull that out of the first term, you're left with 2x. Out of the second term, and you're left with minus 5. So we have now factored the original polynomial. Well, why is this form wonderful? Because if 2 things multiply together to get 0, either this was 0 or this was 0. So this is saying that x is equal to 5 halves or x is equal to negative 1. Those are the 2 zeros of our polynomial. C wanted to know any y-intercepts, but we know that the y-intercept is where x equals 0. So I write that down for the reader, just like I wrote that x-intercepts are where y is equal to 0 for the reader. So when you plug in 0, we would get f of 0 is equal to 2, 0 squared minus 3, 0 minus 5, which is negative 5. So your y-intercept is 0, negative 5. Part D is in donut. Use the leading coefficient to determine its end behavior. Well, since we look at the leading coefficient in this case, or the term that comes in, the leading term is 2x squared. So since this leading term is positive, and the degree is even, then that means that our end behavior is going to be up, up. So that's up, up, end behavior, right? And so the way that we now will write that in pre-calculus terms, up, up, just means that as x goes to positive infinity, y goes to positive infinity. And as x goes to negative infinity, y goes to positive infinity. It goes up on the left and up on the right. That's what we mean by up, up. Then in E, determine if it's even, odd, or neither. Well, in this case, to determine if it's even, odd, or neither, remember, we plug in negative x into the function. If when we plug in this, we get the original back, then our function would be even. If when I plug in negative x, I get not the original, but negative the original, then our function will be odd. So those are really the 2 choices, and that's what happens when we plug in negative x. Either we get the original or the other, but if it does neither of this, then it would be neither even nor odd. So let's see what happens. I take my original function, which is 2 stuff squared minus 3 stuff minus 5, and when I plug in negative x, watch what happens. Negative x squared is just positive x squared, because a negative times a negative is a positive. Negative times negative is plus 3x minus 5. And notice, this does not equal the original, and it also does not equal negative the original. So f is neither even nor odd. And that is 83. So that's 83. Now we're on to 87. It's that whole thing again. Let's do it again. So 87. F of x is equal to 3x minus x cubed. Again, part A is the degree. Well, what I'm going to do is I'm going to write it in descending order before I do anything else. Now it's in a nice form where I can read what's going on. So the degree for part A is 3. It is a cubic polynomial. For B, it wants to know the zeros. We know that zeros The zeros are just the x-intercept, which is where y equals 0. So I set the entire y, or f of x, equal to 0, and I get this. And now that it's set equal to 0, I know that I can factor. So I factor the left-hand side. We only want to begin factoring when we have stuff equal to 0. So let me look. Let's look, and I guess I can first multiply by a negative to make my life easier. So, well, no, let's just pull out an x. So I pull out an x, and what's left? I guess negative x squared plus 3. So that tells me that either x is equal to 0 or negative x squared plus 3 is equal to 0. But that's just trying to tell you that x squared is 3 or x is equal to plus or minus the square root of 3. And this cubic gave us those 3 zeros. C, find the y-intercept. Well, the y-intercept is where x equals 0. And so if I put in 0, I think you quickly see that we get 0. So 0, 0 is that intercept. D is in donut. Use the leading coefficient. Well, the leading term is negative x cubed. Since the leading coefficient is negative and the degree is odd, well, odd means it's either down, up, or up, down. Since it's negative, it's going to be up, down. It's going to want to look like a negative cubic, so it's going to want to look like this. But that means as x goes to negative infinity, y goes to infinity. And as x goes to positive infinity, y goes to negative infinity. That would be up, down. And then E, determine if this thing is even, odd, or neither. As we said last time, you just take your function and you give it negative x and see what happens. In this case, when we give it negative x, what happens? I guess we get x cubed minus 3x. And notice what that is. That is just negative x cubed plus 3x, or in other words, it's just negative, the original, so that means our function is odd. All right. So that is that one. That was number 87. We are plugging along, almost done. Let's look at 89. So 89 says graph the transformed function. So if you look at 89, g of x is equal to x plus 3 squared plus 1. Notice that for any function, we remember that if we change it to f of x minus h plus k, anything that you do on the inside does the opposite of what you would think it would do, left or right, and anything you do on the outside moves it up or down. So here, we could think of this as x minus a negative 3 plus 1. But if that's too confusing, we just know it does the opposite. So x plus 3 means that we move that thing to the left, 3. On the outside, this means we move up 1. So our original parent function, x squared, with its 0 at 0, 0, and a point at 1, 1, has now moved to the left 3, 1, 2, 3, and up 1. So that means it will now open up like this. And let's see, this is going to be negative 3, 1. And this point right here is now going to be negative 2, 2. So notice I started off with a parent function and 2 points on it, and I showed how it all moved. So that's 89, and now on to the last one, number 91. But just to make sure, we go back and we check all our answers, and yes, we check them, and they're all wonderfully correct. for the sake of time, and then we go to 91, which is our last one. It says, look, I've got this function, and it's negative square root of x minus 1. Well, the way to really think about this is you want to work from the inside out. And that's what we did last time, but I didn't talk about it. Oftentimes, the order matters in mathematics, so we're going to be careful here, and we're going to work away from x. And first, I shifted left, and then I moved up. If I always work from inside out, I'm not going to make a mistake in order. So the first thing that happened as I walk away from x and work inside out, I get a negative of my original function, which is going to reflect across the x-axis. And then this is going to move me down. So my original function is this, which looks like that and has the points 0, 0, and 1, 1 on it. Then when I change it into negative the square root of x, it just reflects down here like so. And now I have the point 0, 0, and 1, negative 1. And then when I move it down to negative x, negative square root of x minus 1, then this and this just move down 1. And I'm now at the point 0, negative 1, and 1, negative 2. So here's this function, here is this function, and there's the original. Great work, and I'll see you next time.